Hello, good morning, good evening. No, maybe not evening, but good afternoon anyway. Everyone, my name is Chris Doran. I'm a technical sales specialist for ITM Instruments. Thank you for joining us and our webinar today, brought to you by ITM University. Today's topic is condition monitoring with thermal and acoustic imaging with Teledyne FLIR. We'll be covering a good amount of information throughout the presentation, which should last anywhere between 40-45 minutes, and we'll have a Q&A slot allotted at the end of the presentation. That being said, we do encourage you to ask questions at any point throughout the presentation. You can use the question and/or chat feature to submit all your questions in there. And as mentioned, we'll get to them at the end of the presentation. ITM and Teledyne FLIR have been working closely together for many years. We pride ourselves on being a leading distributor of FLIR in Canada. This is a result of our dedication to offering you our product expertise, service, and our competitive pricing. Getting started today, our presenter is Manny, Eastern Canada District Sales Manager, and he looks after all solutions and segments. Manny has been with FLIR since 2012. After that beautiful presentation and intro, I turn it over to you, Manny.
Thank you, Chris. Appreciate it. Welcome, everybody. Thank you so much for joining our presentation this afternoon. I'll do my best to keep it as interesting as possible, keep you, give you as much information within a reasonable amount of time. Please, if you have any questions towards the end, please ask away. I'm here for, I can't cover everything, that's impossible, but I would love to have discussions and questions that I can really address. This is why we like to do this kind of a simple presentation, and then we can elaborate as we go on. During the presentation, I will shut off my camera because for bandwidth issues and make sure there's no need for any interruptions, but I will turn it back on towards the end when you open the question period. Okay, so let me just start. So just to reintroduce myself again, my name is Manny Alsad. I am the Regional Sales Manager for Eastern Canada. I've been with FLIR for over 10 years now, and I cover a multitude of segments, which I'll show you shortly. We are now called Teledyne FLIR. If you're familiar with FLIR, FLIR's been around for a very long time. But as of May of 2021, last year, we were bought out by a company called Teledyne. Teledyne has now become the largest company in the world with variable sensors and all kinds of technologies. Teledyne makes sensors in X-ray, gamma, microwave, radio, and now, of course, infrared imaging. So they really cover the broad spectrum of different sensor technologies in the world. We are under the FLIR, Teledyne FLIR segment, which is the infrared imaging and other technologies as well. We will be discussing the condition monitoring and predictive maintenance. Why is it important? What are some of the challenges? And also talking about the thermal and acoustic technologies that we offer. There is obviously other technologies as well, but we're just going to be concentrating on those two and some of the things that go with it in this presentation. Make sure the point of this presentation is to ensuring the health of your equipment is what we're trying to achieve. Here are some of the segments that I manage as well. There's optical gas imaging. Optical gas imaging is we have cameras that detect leaks for methane, propane, any type of industries, carbon dioxide, monoxide. Public safety, these are law enforcement cameras, binoculars, or the firefighter cameras. Then we have security, perimeter security, continuous condition monitoring as well. These are fixed type cameras for various applications, R&D and science, and then marine electronics. This is actually not part of my segment, but it is another division that gets handles these technologies. For today's presentation, we'll just be focusing on the condition monitoring application. What is condition monitoring? So the idea of condition monitoring is to create a program that measures or monitors temperature, vibration, sound, anything of that sort of equipment. Make sure that any early signs of failure or breakdown are noticed way ahead of time to avoid any costly breakdown. So that way you avoid any interruption of production, improve the safety, and obviously lower the costs for operation. You don't want to have a downtime the worst time. The markets we'll be looking at today is the utilities, manufacturing, for welding and all kinds of things, petrochemical facilities and those. So the technology of condition monitoring does cover all these different segments. In the building and the facilities world, we actually have other product lines called the X-Tech line that has a lot more instruments for looking at air quality, sound, light levels as well. So if you'd like more information, please reach out to ITM and they'll be glad to help you out and get you all that information as well. So this is nothing that most industries never want to hear about this, which is the downtime or unplanned downtime. And so when something happens that is unexpected, which means that you have to stop your production, change over equipment, tool changeover, job changeover, you have to pay people overtime, triple time, bring people in, you don't have the right people available. So it just adds a lot of cost for any unplanned downtime or any unplanned failure. There's been a study done by the research firm, analysts from Aberdeen Research. 82% of the companies who experienced unplanned downtime over the last 3 years, the average cost was $260,000 an hour. That's in US dollars. Just to give you an idea that for industry, this could be in the hundreds of thousands of dollars of cost when you have an unplanned or unexpected failure or downtime. In the equipment lifecycle, so anything that gets built, even us, there is a cycle, a life cycle for it. We call this curve the DIPF curve, which is the original design, installation of the asset, point of the failure where it starts, and then obviously the functional failure. Design phase is where the product is designed and built. Installation is where the product is installed and used. And there's various methods of installing equipment and so on and so forth, depending on what it may be. Point of failure, this is where things start to fail. Now, everything will fail eventually. It's just the nature of things. There's nothing that lasts forever. You have to have the right technologies to be able to start detecting these early failures. One methodology is ultrasound or ultrasonic spike, vibration, and obviously thermal imaging, where there's hot heat being generated by the failures. For today, we're just going to be focusing on the ultrasonic and the thermography. I'm not going to be talking about vibration, but there is, if you ever need information, we do have vibration sensors that can monitor vibration of equipment installed at various things. So it gives you kind of an early warning sign. If something was badly aligned, or if something is there's a wearing out bearings in a motor and it's starting to vibrate more than natural, more than normal, the vibration instruments will tell you that, so it gives you a warning. Then you can go and do the diagnostic with the ultrasound camera and or the thermometer. If you look at the equipment life cycle, a motor, if you decide to install a motor, whatever number of horsepower, without any type of condition monitoring, there's no maintenance, nothing like that, until you run it onto failure. Average cost, again, this is kind of an approximation, could be around $18 US a horsepower. We have a 1,000 horsepower motor, it's $18,000. So it's a costly option when the motor fails, especially if you have multiple motors. A lot of industry has a lot of motors for all kinds of things. If you do kind of do a regular maintenance, just ask the guy to walk around and do a check every now and then, you might pick things up. You can do condition-based, where now you're starting to look for specific things. You can start detecting more. And then if you do proactive, where you really have a program that includes ultrasound, vibration, and thermography, then you can really catch early failure points. Remember the graph I showed you before? You might start to detect things much earlier to avoid, or at least plan for, any potential failure in the future. So that way you can really save on costs. So we call this the mean time, or the MTBF, which is the mean time between failures. You want to increase that time between failures by creating this type of program. This is the idea of the condition monitoring using the technology. Is you don't want to have short periods of time between failures. You want to have long periods of time, if none at all. That's what you're trying to do. It's because that way you can run things as long as possible without the need. It's almost like, if you think about Formula One racing. They try and run their, any of the racing categories. They try and run the tires of the car as long as possible without the need to go into the pit to change the tires. That way they continue. Why? Because they want to maximize their MTBF between each pit stop. If you can think about it that same way, is you want to maximize the time between failures, so you don't have to have failure situations where unexpected. You try and control the failures. We had a statement from General Motors, reliability engineer. They were using our cameras for just regular checks and all that, but they realized that if you don't get the failures out, you can actually you can have catastrophic failures. If you don't have a proper program in place, you can actually have some major catastrophic failures. And that's why they realized, we need to do more than just the basic, just quick walk around check on. We need to really have a program in place. Now we offer, as I mentioned before, a variety of solutions for industry. In today's presentation is going to be acoustic imaging and the thermography, but we have quality, air quality, light sensors, monopolies, all kinds of things. So please, if you want to have more information, reach out to ITM, and we'd love to help you get that information to you. And I'll be happy, myself or any of my colleagues in different regions will be happy to present you some of the products and more details. Now, what is thermal imaging and how can it be applied? Typically, heat or any temperature rise in pretty much anything has a representative of something. It's an anomaly. If we have fevers and or equipment failure, there's something happening, right? Technology, the cameras, infrared cameras can detect early warning signs, give you a heads up. So you can take proactive measures to avoid any costly shutdown. Remember, everything fails. That we know. It's impossible to keep anything running forever. The important thing is controlling when it fails so it doesn't fail for a long time and prolonging the time between the failures, as I mentioned before. So that's what you're trying to do, is really reduce the risk and increase the amount of time of visibility. Thermal imaging keeps the user safe. It's non-contact, so you don't have to be close to anything. You can do it from far away, and you're measuring the temperature of every single pixel. Basically, you're getting pixel by pixel measurement of the object in front of you. So that's a great part, is you're not touching anything, you're not intruding on any safety, you're outside of the safety zone. And depending on the the resolution lens combination, you can really do great inspections from far away distance. Plus, it is, we call it a two-dimensional thing, which means what? You're getting a quality. In this particular image, this is a kind of a stitched up image together, multiple images. You're seeing where the water damage. So what you're seeing right here is water damage in the floor of this building. The image is showing you how far away is this damage. But now you also can get a quantity value of what the temperature is or the humidity level is by the various instruments that we have. So we call it a two-dimensional. You're getting a quality and the quantity as well. It gives you a really good overview, and you can really analyze. Because now you have images, you can create historical records as well. Here we have a video of a drone flying with a thermal camera on the left, visual camera on the right. In the thermal camera, you can see that you can see the landing strip easily, the roads, no issues at all. The camera can detect all the details, you know where you are, where you're going to. With the visual camera here on the right, you can see lights, but you really can't make out what you're seeing. That's the advantage of thermal. Thermal doesn't get impacted by sunlight, daylight, or sun. It sees through anything. So we can capture in real time fast-moving targets, depending obviously how fast. We have different models for different applications and changing thermal anomalies as well. Just to show you an example, this is a fuse box that the thermographers did a check on. There was just by outside temperature, there was a 7-degree delta between outside of the box to the ambient temperature. When they opened it up, actually, they realized it was actually 175 degrees, which is typical. You're seeing this a lot of times in mechanical and the electrical applications. You might measure something that's hot on the outside, but typically the inside is a lot hotter. It's just by the time it gets to the outside, there's that. So that kind of, just to show that 7-degree rise can mean catastrophic failure inside the box or inside the equipment. Remember, you're doing this from a distance, so you're not necessarily touching the box. You can do it from far away. Another example, looking at three fuse junctions. There was an issue with this one. They thought originally it was in the connection and all that, but they realized it was, you know what, it's actually something beforehand. The wire is heating up. The failure is happening prior to this point, not at this particular point as well. Same thing with this image. We have, looking at these 9 set of wires. This particular wire, if you look at it, the problem is actually, when you open up a cabinet, the problem is not here. You notice the temperature gets hotter as it gets away, which tells us that the problem is further away from where the actual connection point. So it's not at the connection point, it's actually happening from prior to either overloaded circuit, something of that sort, but something is causing it. You can really see it easily and measure the temperature using a thermal imaging camera. So the applications for thermal imaging is a variety, right? It's endless. It really is. There's no there's mechanical, building, petrochemical, and there's so many more that we work with every day. I know I've done all kinds of demos and applications over the years, and it just never ends. And I learn new ones every day. Now, how do they work? This is actually an interesting one, because a lot of people confuse thermal cameras with a visual camera, which is not the same thing. So everything in the universe emits IR energy or IR waves. When anything is over 0 Kelvin, which is the absolute temperature, As soon as it has any kind of energy, it emits IR energy to varying degrees. When the temperature is cold, it's not giving out a lot of energy. So in the case of a glass full of water with ice, it's not giving out a lot of energy, so it typically looks darker for the camera. It's not seeing much of the energy. For objects that are much hotter, like this case of a flame, it's giving out a lot of energy. A lot of photons are being shot out and being captured by the detector. And again, this is a different wavelength. This is not visible light. This is completely off the waveband from visible light. Visible light is very small in the electromagnetic spectrum. Infrared light is much further away. And if you can just think about it, when you go outside in the summertime, hopefully we'll have sun soon, heat, you will feel that heat from the sun. That's infrared energy. The heaters you have at home or fireplace or stove, whatever, and all that heat you feel is infrared energy. So we don't see it, you typically feel it, depending on what it is. On the top image here, you're seeing these are the actual pixels of a thermal detector. You can imagine a grid array of multiple pixels, but this is what a typical pixel looks like. The new design is a little bit different. This is one of our older designs, but if you can imagine this, when a photon, infrared, hits the detector, it charges up the detector. We apply an advanced calculation called Stephen Boltzmann law, which we put a value to that intensity. So we have different intensities per pixel, and each value will have a color. And that's why we're able to create an image based upon what the energy. So imagine all photons are hitting the detectors. There's advanced calculation being done. We do an intensity, which we generate an image from. Now, in the similar world, in the visible world, is there something similar, but it's a color based, not a temperature based. Now, one of the most important things that we always explain to everybody is very important to get more precision is the number of pixels. More pixels, more precise, more accurate measurement, more details. In this case here, on the bottom left, you see there's an image with 8 by 8 pixels. As I make my way to the right, I start seeing that this is a face versus the initial image. I can't tell what this is. More pixels, I have a lot more detail. I know this is the side view of a person's face. In the same token, when you have different technologies, there's a lot of different cameras up in the marketplace. So we always tell people, make sure you understand what pixel resolution is, because that's very critical in choosing the right instrument, right? In this case, we have an instrument on the left. Resolution is not as strong. It doesn't show the wires. If you look at these wires right here, you don't see the wires because not enough pixels. You see there's a hotspot, but you can't tell where it's coming. Is it the wire or is it the fuse? Right here, you can actually see on the right, the wire is right in the front. Why do you see it? Because even though the screen size is the same, this camera has more pixels than the one on the right. Let's look at another example. This is a series of motor banks with splice wire. Right there. We're noticing one splice is hot. If we just take a low resolution camera where we get one pixel kind of over covering the whole splice, like in this case, that pixel is going to average out temperature here, here, and whatever's on the installer. So in this case, it's going to give you around 79, let's say 80 degrees. We get a better resolution camera and start seeing that, oh, we went up a little bit, so there's a typo here. It's about 98 degrees and 99 degrees Fahrenheit. Then if we get to higher resolution, so now we're putting more pixels, so smaller pixels, more pixels to the target. If you look here, now I have basically 9 3 by 3 pixels on this one target. Now I'm 190. If you imagine, I went from 79, or let's say 80 degrees Fahrenheit, to 120 degrees Fahrenheit. So a 40-degree difference by increasing resolution. Now, that's decision making, because you might say to yourself, you have a low resolution camera, okay, something to worry about, but nothing critical. Versus if you have the right resolution camera, you know what, there's a problem, we better take care of this right away. Because that's a very important for decision making. Because remember, you want to make sure you capture failures in time to avoid unplanned shutdown of failures. Right? If you don't have the ability to, buy the highest resolution camera, well, great news. We have different lenses that are available for different cameras. In our handheld cameras, or even in our fixed model cameras, you have a range of wide-angle lenses, regular standard lenses we call it, or zoom. Again, if you look at this example, at this connection point, with a wide-angle lens, so the same resolution camera, it's giving you 181 degrees. Now we use a standard lens, which shows us more pixels on target. I'm getting 188. If finally, when we really get the right amount of pixels on target, we're starting to see much more. Our decision making is really different from this point to that point. So keep that in mind. You might not have the budget to buy the highest resolution camera, but at least keep in mind that there might be lenses available to give you a better zoom capability to do your diagnostics. Also, FLIR has a patented technology we've had for a long time now, where we superimpose the digital image on top of the thermal image. That's why you're able to see this detailed text. I'm going to do this little video to kind of show you what it looks like. So we take the outline from the visible image and we overlay it on top of the thermal image. So a thermal image without that technology would look like this. You don't see any of the text because thermal doesn't see detail, visual detail, only visual. But what it is, we outline and put it on top. The nice part about this is now you can identify your targets. Instead of doing the ping pong effect, bouncing between visual and thermal left and right, trying to look at pictures to see where this hotspot is, now you have all the details of the visual overlaid in your thermal. So you're 100% thermal with visual detail. Like we're the only ones in the world that have it. Now, part of infrared thermal imaging, which is very important, is infrared windows. It's kind of a hand-in-hand technology, especially if you have a lot of cabinets, electrical, installations and cabinets and all that, electrical rooms. Why? Because arc flash safety. Arc flash is a major problem in the electrical world. Unattended or people who are not prepared for it, people have died, been injured. A lot of things have happened because of arc flash for people who are not prepared, not familiar with it. So we always make sure and recommend to reduce the risk is always put an IR window. I'm not going to get into all the different types, but we have all kinds. We have round ones, stainless steel, aluminum. We have rectangular ones, different sizes. So we have plenty of different types available for IR windows. I'm not going to get into specifics. I can, if you want, I can share more information, but in this presentation, we're just going to focus on the technology, not the specifics of it. But at least this allows you to keep the cabin doors closed, so this workers can stay safe, and we reduce the risk of arc flash. Make it more reliable. So again, by doing regular condition monitoring now, without having to open the cabinet, because it's just opening the window. I'll show you a picture in the next slide. Makes it easy to do inspections, and you can document everything because you have a camera. You can capture images and/or videos. Plus, you can improve the cost. It doesn't take as long to set up. A person wearing a Cat 4 suit versus a Cat 2 suit takes a lot less time to set up basically versus that other person. Plus, on a hot day in the summer, you don't want to be wearing those hot suits. Person on the left is wearing just basically, glasses and safety glasses and a hat and yellow vest. Person on the right has got a Cat 4 suit. He's fully suited up, gloves and everything else. So obviously, to set this up, do measurements and control cameras is a lot more time-consuming and harder versus someone just doing this. You open up the window, look inside the cabinet, and you see. We actually have a calculator available for people to use. I'm going to show you the cost difference of without IR windows versus with IR windows, how much you can save. Now, another new technology. And this is not thermal imaging, this is acoustic. Whereas thermal looking at temperature, acoustic is looking at sound. Specifically ultrasound. Ultrasound is high frequency waves. We don't hear them. They're above our hearing ability. It's produced by things when they start, equipment, electrical, anything that can basically vibrate, or let's say there's air leaks, can create ultrasound. It's very directional. One thing about ultrasound frequencies is they're very directional. So you can localize them easily. You can give you early warning. Remember, I told you in the beginning of the curve, the DPIF curve of the condition monitoring or the failure, that ultrasound can be a very early warning system to detect starting points. So it gives you time to react or plan out your repairs or shutdowns and all that. You don't have to kind of be unexpected, because unplanned is very costly. So it can really add a lot of cost savings to your program. Typical applications for ultrasound is partial discharge, burst air leak or vacuum system. Obviously, there's other applications, but the ones we've been kind of talking about the most since the introduction, that we introduced this product about 2 years ago, has been those three on the top. For compressed air, which is a big problem actually in the industry, compressed air in a pressurized system, when it leaks, it kind of creates this vortex and starts, coming out of the sides. And all this is actually costly, if you think about it. The Department of Energy in the US estimates 30% of all the manufacturing facilities use about 30% of their electricity for compressed air. So that's basically a third of the cost of compressed air is being lost. When you calculate the cost, so if you're running a 200 horsepower compressor at, let's say, 11 cents per watt, depending where you are, in Quebec, so rates are a bit cheaper. Some other parts of Canada are higher. It's a major cost just for one compressor, if you think about it. Imagine if you run a mini compressor. So just that on its own just for compressed air, it's a major issue. And this is typically what you would see with an acoustic imager. Now we have different models. We have actually 3 different models. And they're all handheld, but one is used for compressed air leaks, one is used for partial discharge, or one does both. The images all look the same. In this particular case, you're getting a black and white visual image. This is not a thermal radiometric image, just a pure black and white visual image. But any of the acoustic sound is being concentrated into the image to show you the intensity or the frequency. Another example of an air leak of the system. It's a refrigeration gas leak right there. You've seen it picking up in the image as well. Again, black and white image, so we can easily identify what we're looking at, but it's showing you where the point of air or the ultrasound is coming from. Remember, this is a camera, so you plug it in, you start it up, you can start seeing this right away. There's nothing fancy, it just starts right away. Now, with our reporting, we have 2 different ways of reporting with these cameras, either in the cloud and or on your desktop using local software. Both of them will give you the ability to do calculated cost or the leak rate cost if you enter in the value. So we enter in the value of kilowatt hours, it'll calculate the leak size, and that'll say, you know what, this is costing you, this particular leak is costing so much per year. When you present this for your management team or insurance company, say, I need to fix this because this is what this costs, this is how much you can save. Gives you a justification, schedule out your time and how to do it. This can be done with the PC or the cloud software. Now, partial discharge, what is that in the electrical world? Well, you might have heard of the term corona. If you haven't, corona is basically ionization of the fluid air around any conductor. We don't see it. Well, you might see sometimes, but typically we don't see it. But that eventually creates surface tracking. And there's cracks on that, and eventually electrical breakdown or arcing, kind of similar to the arc flash. When things fail, when the insulators fail, you can have arcing happening, where the insulators are no longer protecting the circuit from the rest of the ground, so it loses that capacity and just arcs away, and basically it's a shutdown situation. In this example, we have a faulty insulator. We see this a lot, right? Why? Because insulators, whatever material they might be made of, impacted by temperature, especially in our climates, there's cold and hot. This material will expand and contract, which eventually causes cracks. Those cracks allow water in, and it weakens the insulation properties. What happens is they start vibrating. Electricity starts, vibrating this and that's creating ultrasound frequencies that we don't hear, but with the SI-124, we'll pick it up. And we can localize it. We can tell the intensity. Now, the unit has the ability to have artificial intelligence to tell you what it is, what's severe. I'm going to show you this in a few more examples, and what severity is. Does it be fixed right away, or what the situation would be. Another example, faulty insulator, is a floating discharge happening between 2 insulators. If you look here, so on the cloud or on the software, PC software, you'll have 3 parameters to input, which you put in your distance to the target, the voltage of the circuit you're looking at, and what the component or location might be. The program or the software, cloud or PC-based, will give you AI. It gives you severity with a description and a recommendation, what needs to be done automatically based on the frequency that's captured, the pattern that's captured, and the inputs that the user puts in. It'll tell you, you know what, this is very high risk, this is medium risk, you should do such and such to address it right away. Now, all this can't be done without having all the software. FLIR, Teledyne FLIR, we have a package suite called the Thermal Studio Suite, which combines a variety of products to give you that full solution. Thermal Studio is the software, which comes with 3 versions. There's a free basic version, there is a starter limited version, and there's the Pro, which has abilities to do batch processing, route creator, and so on and so forth. Now, route creator is an add-on to the software to allow you to create a route to tell a person where to go next and put criticalities in the camera. Now, this only works for thermal imaging cameras for now. what the person does when they're doing a thermography inspection, they look at their list, they open up that location, and they'll give them messages of what is the situation. They can enter that in, and then it gets fed back into the reporting side. With the ultrasound camera, we have a plugin. It comes when you buy this camera. It gets added to Thermal Studio, where it analyzes the leak rates and shows you what it might be. Is it severity, or if it's a cost of what the air leak analysis. So all this suite allows you to really do a great diagnostic and condition monitoring program under the Thermal Studio suite software. So the Pro, or the starter version, will reduce because of the way it's designed, it reduces the time to make a report very easily. There's so many great features. I can show some of them all that later on. Making add rapid reports, quick analysis, formula functions, everything can be automated literally to do quick reports using the software. In this case, it's thermal, but you also have the ability to do the acoustic imaging. And again, in the acoustic imaging, you have the ability to add the severity, with the three inputs of the distance, voltage, and the location, and we'll do a severity and recommendation in the different patterns along with the image as well. So these two sections of technology can be combined into one report. You can even have pictures side by side if you want. So this is it for my portion of the presentation. I'm going to open up now for questions. I'm going to put my camera back on. There you go. Yes, Chris.
Perfect. Well, thank you very much, Manny. A lot of information was covered there, but now is the time for you guys to take advantage of having an expert like Manny connected with us. So we have about 25 minutes or so, so please get in all the questions that you possibly can. You can use the chat feature or the question and answer feature. While you're getting all those questions in, I'll just give you a quick note. For any product-related questions, camera-specific questions, application-specific questions, pricing, availability, trainings that are offered by ITC, etc., we're going to encourage you to go directly to our website, itm.com. You'll find our list of products, pricing, availability, data sheets, along with contact information to get in touch with myself, one of our sales staff, or one of our technical support staff as well, that can help you answer any and all of your questions.
Folks, I can attest that all the ATM team, a lot of them are level 3, level 2 thermographers, well trained, well versed in the technologies and all that. They know their stuff. I think it's a great partner that helps us out a lot. So please reach out to them and they'll give you all the information you need.
Greatly appreciated. We did have a question. There is a training option for anyone who is looking for a form of certification when it comes to thermography or application-specific certification as well, electric application, et cetera, et cetera. All the courses, all the upcoming courses offered by ITC can be found on our training page on itm.com.
And we even have acoustic training as well. I'm not sure it's a 3-day, 4-day, but on the ITC website that ITM can send you links to and all that, we'll give you information about acoustic training as well.
Fantastic. Okay, so let's get into it. We have a question from Russell. What is the recommended IR resolution for a maintenance pro in a manufacturing facility?
Well, that's a good one, Russell. Thank you for that question. So that's actually, it depends. It depends on what type, how distances, right? If you're close up to your equipment, you can go with low resolution. Far away from your equipment, you might go higher resolution, but remember, there's option of lenses. So exact recommended, I always tell them go 640, 480 if you can. That's kind of the new norm. It used to be 320 by 240 pixels. That was kind of, I would say about 5 years ago, that was kind of the standard. Everybody loved 320, 240. It was affordable. It was vast. You have different models that do that resolution. You can add lenses. Today, price points have gone down. So now the 640, 480 pixel resolution. Now, if you do a calculation, 320 by 240, that's 76,400 some odd pixels, right? If you do the 640 by 480, you're getting about 300,000. So you're getting basically 4 times more pixels for the same boxing, for a different camera, but at the same distance. So which allows you to measure basically something 4 times smaller or something four times away, further away than your 2.24. I recommend the highest resolution possible for budget, just because it gives you the ability to see things, but that depends on the installation. Depends on what kind of equipment you want to inspect. Depends on, if you have a substation, if you have large tanks, if you have things far away, or is everything close up? It's a small factory. It really depends on what kind of, are you doing reporting? Are you planning to submit this? If you're going to, and I always recommend, do a condition monitoring program, meaning set up something of specific frequency using the acoustic imaging and all that, because you want to, if you just do it every now and then, every Monday morning you send out the guys, they walk around, see if anything hot, tighten things up. The typical way, the old way of doing things was check all the connections. Prior to that, people would touch things with their hand. Don't do that anymore. They would just walk around with the camera. Oh, that's hot. I'm going to tighten the screw. That's good. Problem is, you're going to miss something, right? It always happens. And what happens is it happens at the worst time. It's Saturday night, 3 o'clock in the morning. You're having drinks with your buddies and all that, or just having a party. Somebody calls you, says it shut down. Now you got to rush to the, fact that you're not feeling well. Call people, fly equipment in, pay extra money, and all that's cost you a fortune because you didn't have a program in. So by having the right equipment for your needs, and you can set up a condition monitoring program, you do well off.
Perfect. I'm sure Russ will be very happy with that answer. So next question comes from Meta. Can we detect with a thermal imager rust in a pipeline, like a gas pipeline? And they went a little bit more direct that this particular pipe that they're talking about is covered with an acoustic insulation.
Okay, I don't know. I've never done it before, so the question would be is maybe. Typically, any delamination of surfaces will cause more heat loss. I've seen it in a variety of cement, ovens, and all kinds of things. Whenever there's any kind of weakness in the insulating walls of any material, typically there's more heat loss, or depending, obviously, if it's a cool load, that will show up. But I can't say for sure. I've never tried it myself. We do actually also have thickness gauge testers. That's another thing we offer through the X-Tech line, where you can actually, it's a great tool to use it. So if you suspect, let's say you do a thermography session, you've seen something anomaly, the thermal anomaly on the surface, you can take a thickness gauge tester and check the thickness compared to different areas. And you'll be able to see, hey, is the thickness difference in this part? Because this equipment, it's like a microphone, or let's say a transmitter, it sends out an ultrasound frequency and rebounds. And depending on the depth of how the frequency comes, I can determine how thick it is. And this allows you to see this delamination, if there's any kind of rust. We have that as well. But that's, again, you're adding on a tool, but it's great because you localize it with the camera, say, I suspect there's something there, but now I want to quantify what it is. You can check the thickness. If you know the pipe should be 2 inches thick and you're getting 1.5 inches, or something is odd, or something is changing and all that, there's a weakness there, and that's potential point of failure. You don't want to have a burst pipeline at the worst time.
Definitely. Okay, and just a quick reminder, please use the question or the chat function to submit all your questions. Still have plenty of time to get them all in and have them answered. Next question comes from Pierre. If a client gets an IR or an acoustic inspection, can the reports be done and submitted using the same software on the same report, or do they have to be completely individual?
Same software. So Thermal Studio Suite. So all three. You have the basic, the standard, or the starter, and the pro version. They can all do the thermal and the acoustic report together. The pro has a lot more advanced functionalities and features that the other versions do not have. If you want to do custom templates, you have a lot of clients, you want to create a custom template for each client. The starter version, which is a paid program, only gives you 5. The pro is unlimited. The pro version, if you have hundreds of thermal images and you want to change them all, and you have a batch functionality that you don't have the other. So it depends on what you need. You can ask ITM, they'll send you a comparison of the different packages. But the answer is yes, you can do acoustic and thermal in one report continuously.
Fantastic. So the next question is a two-parter. We'll go with the first part specifically. So Sandy asks, how often should a handheld camera get calibrated?
Good question. And I love, this has always been a great question because everyone's like, oh, you guys say, once a year. Honestly, there is no set frequency of calibration. If you internally in your company or your sector or your industry requires instruments of measurement, whatever they may be, whether it's air, pressure, voltage, amperage, that need to be calibrated for ISO, for insurance, whatever the case may be, then you should follow that same set of guidelines for the camera. If you don't, you're not required. Now, you can do a check. I recommend ITM, they do a calibration check, which basically, in regard to thermal imaging cameras, they point it to different black bodies and confirm the temperature reading is good. But if you want a factory certificate calibration, so basically our technicians make sure that the temperature is to factory spec after a number of years with a certificate, a current certificate, then it has to be sent back to our Toronto service center. Now, Clear is the only one that has a service center of our, where we do our full factory calibration with certificate in Canada, which means there's no exports, there's no documentation, nothing. You don't need to do anything. You just send it to ITM, ITM sends it to us. We'll do everything for you guys on that. That's the way I always recommend. So is it based on what you need? We have some customers that require 3-month calibration. That's what they send. Every 3 months, they send a camera to us. We get them calibrated with certificate and send it back to them. Okay, they said, what's the second part?
Fantastic. There is a second part of the question, and Sandy, just to address you specifically, for a application-specific question like you did pose, I would suggest going to itm.com, finding our contact info. We have our email, our phone number, as well as the chat. You can connect with an expert, and we can address recommendation for your specific application directly. Next question we have. Let's see here.
Folks, don't be shy. Ask away. I'm here for any questions.
So going back to the acoustic camera, the SI-124, how many microphones does it have?
124. So the camera has 124 microphones. It measures frequencies from 2 kilohertz up to 35 kilohertz. More microphones, which means more easier to localize from far away, right? Because you have much more broader range of capturing without getting overboard. It's a camera to carry and hold. It's not really like if I go back to the image of the camera here. It's a handheld camera. This is a back view. Well, this is a screen. That's the front. So you see all the microphones of the visual camera in the center. 124 microphones, 2 to 35 kilohertz. You don't want to go anything above 35 kilohertz because there's different technologies out there. I'll go up to 100 kilohertz. The higher the frequency, the shorter the distance they travel. If you guys are familiar with home theater systems, bass sounds, you don't have to put a subwoofer in a specific location. They travel far. And then when somebody, I'm sure when you guys were young, if you had a subwoofer in your car, you travel, you can hear a mile away, the whole house is shaking. That's because low frequency sounds travel very far. High frequency sounds are very directional. So that's why typically, the center speaker of a home theater or anything, you hear it as it's traveling. The high sound, it's very directional. So higher the frequency, much more directional. They don't travel far. You got to go much closer to the equipment. So you're able to measure with the SI-124 up to 300 feet away. So quite far. Any higher, you basically got to get closer and closer and closer to the point of it's outside the safety zone. What you need to do.
So, and that was one of the questions in terms of distance. So that's great. Another question that we had was when comparing noisy areas to less noisy areas. So we'll just use the example. Is there any filtering mechanism or anything that the SI-124 has to kind of filter out more noisy areas?
Right. So typically in the outside environment, there's less ultrasound frequencies, depending on what you're looking at. Obviously, depending on the installation versus inside, there's a lot more echoing going on. But the camera's AI technology and the way it's designed, it recognizes the sounds or the frequencies, so it knows how to ignore. And there's filtering capabilities in the camera, and it's pretty much automatic. Honestly, there's not much typically you need to adjust for. It's pretty straight. You plug it in and it's ready to go. But it distinguishes this is an air leak, this is a partial discharge, and ignores everything else. There's AI that's always recognizing what it is and giving you that information.
Fantastic. So just to address Jean-Claude, your question is extremely application specific. So again, I'll remind you for something like that, we are going to take note of your question and our local sales rep and or expert in your area is going to contact you directly to be able to talk about exactly what you're looking for and what you're looking to achieve. This was IR window specific. So we'll have someone contact you directly at the end of the presentation, either today or tomorrow, to be able to address your question directly. So next question. We spoke about lifespan earlier, basically for anything. Stan wants to know the average lifespan of a typical camera, if you've got that.
Honestly, we have cameras. I'm begging customers they're 20 years old. They're still working. Variety of customers, Hydro Quebec, NB Power, all those guys, they have cameras. I mean, our cameras, it's a testament to the product quality. They're too good. I'm trying to be like, guys, there's so much newer out there and all that, but cameras can last forever. And our testament to so FLIR's warranty, we have some of the best warranties in the industry. On the thermal imaging cameras, you got a 2-year parts and labor. For cameras that have removable batteries, you can get 5 years on the batteries, the lithium-ion batteries, and then 10 years on the detector, which is the best. Nobody else has. So that means if your detector fails on year 9 or year 10 of your camera, we will replace it no cost to you, which is the most expensive part. Think about it. Out of a thermal imaging camera, LCD screen, buttons, and all that, that's nothing. The detector, which is the most crucial part, that's what's measuring temperature. If it fails, you got 10 years worth of warranty. And also keep in mind, the parts and labor is 2 years, but we do offer extended. You can get 3 years, you can get 4 years. We do sell those. It's not a problem at all. We can give you up to 5 years if you wanted to. A lot of options, but for the detector, nobody else in the industry has it. Thermal detector is 10 years on our fixed or our handheld camera.
Fantastic. So again, we have a little less than 10 minutes left. So we have a lot of questions already in the queue, but please feel free, use the chat feature, use the question feature. If we don't get to your question during the presentation, so in the next 10 minutes or so, we will reach out to you directly to be able to answer. So the next question comes from Remy. Is there a minimum or maximum leak size that can be detected with the acoustic imager? So he goes specifics, liter per minute or anything. Is there a minimum or a maximum?
I'll have to look into it. As long so it's more if it's not a minimum leak size, it's if the leaks are pressurized. If there's no pressure, if the whatever gas or air in the piping in the same pressure as the outside, means there's no pressure, there's no vortices being made, there's no ultrasound, so the camera will not pick it up. If it's a small leak, but it's under pressure, higher pressure than the atmospheric pressure, where it creates that push and creates that vortices, the camera will pick it up. Now, I don't know if there's a specific value. Chris, send me that. I can ask our product specialist and say, have we ever done a study for the leak size? I know in our acoustic, we don't have that information. In our gas imaging cameras, so the optical gas imaging, I mentioned that to you before, depending on the gas. So I'll give you an example. In the methane leaks, propane leaks, you can get down to 2 particles per million. So if you imagine, this was a laboratory test done where they took this third party, imagine a 1 cubic area of space, 1 cubic yard area of space, where they looked at the lens and said, you know what, we can pick up particles down to 2 ppm. That's very small for gas leaks and all that picked up, but these are specialized cameras. This is not that's thermal imaging with a special filtering, looking for a specific type of leaks. We have for methane and propane, we have for carbon dioxide, carbon monoxide, we have for refrigerant gases, we have for SF6, we have all kinds of cameras for, but that's not acoustic, that's thermal imaging. But if you want that information, I can ask the specialist and see if there's a specific value. You can definitely check it out.
This is I mean, it's application specific, but I think it's worth mentioning. Is there any way to distinguish between a loose connection on a breaker versus a bad connection or a bad breaker on a panel board using a camera?
I guess so. A bad breaker, which means what is bad? Is it corroded or is it a defect? Obviously, typically one of those two will be hotter. I'm not an expert in that field to say specifically, but I imagine that the temperature delta would be higher for those versus just a loose connection. And that's typically what a lot of companies will do. The most common that.
There we go.
Can you guys hear me
We just,
still?
yeah, we lost you for a couple seconds there.
Yeah, sorry about that. It says my connection got lost for whatever reason. Anyway, so as I was saying, I can ask, if you guys want specific, I can ask some of my specialists if they have any kind of a paper on this, but for maybe for my PC. But as far as I know, yes, corroded potentially should be hotter.
Perfect. So again, just a few minutes left. We do have a couple questions in the queue, but again, please use the chat feature, the question feature, just to get those last minute questions in there so we can try and answer them live. And if not, we'll contact you directly with the answer to your questions. So is there a possibility to use the acoustic imager when using, I guess, in an electrical, trying to detect an electrical motor fail or a gearbox fail?
Yeah, so if you imagine, if the motor vibrating, which means it's now something is out of balance, or the bearings are failing, they start generating. Actually, that's one of the quickest way to check bearing failure is to use an acoustic imager, because you can see it right away. And what's nice about an acoustic imager versus a thermal imager, if you lubricate the bearings, it's gone, right? That frequency vibration, or let's say you rebalance the motor, it's gone. The frequency is gone. So you right away know that, hey, it's fixed. A thermal imager, well, guess what? You have to wait for it to run, to say, hey, it's been running for such a time. Has it heated up? No, it's not heating up. So imagine, even though thermal is the best for other applications, but in the case of acoustic, it really picks up things early on. So yes, it can be used to look for problems with bearings, and if something is unbalanced, it would create. When a motor is unbalanced, bearings are going to be impacted, guaranteed, right? You won't see the vibration of the motor. You'll see the bearings, hey, they're not rubbing properly. They're starting to create acoustic ultrasound. You can probably pick it up with the SR124. But we also have vibration sensors. The best thing to do, we have specialized vibration sensors. You install them on the motors. They're wireless. They transmit 24 hours a day for years to a wireless sensor. And if anything is out of balance, you know, if it checks the 3 axes, X, Y, Z, you'll see it in the graph and say, look, I can even calculate, you can even do an RPM calculation to see what the motor is looking at if something's not right. So there's a lot available. And this today, we just focus on acoustic and thermal. We have other types of sensors as well.
Fantastic. Okay, so next question is from Pierre, and I'll add a little bit in here. Do any of the thermal imaging cameras, as well as the acoustic camera, have a distant measuring device or a laser built into the camera to be able to detect distance?
Yes, so starting from our E54 handheld camera, so EXX series we call it, or the T series, so you see T530, T540, T800, T1020, they have a laser pointer that shows you what you're looking at and also measures the distance. And some of the models will actually calculate the area. So when you're using a box tool or a zone tool, you can actually calculate the area, and that can be transferred to the report as well. The other cameras that don't have it, if you know kind of the distance you're at, you can actually calculate the area or the size of the target. But distance measurement directly on camera are the handhelds E54 and go on.
Perfect. So just a couple minutes.
Sorry, I do want to say one thing. We have a lot of distance measurement tools as well. Under the XTech brand name, there's a lot of XTech tools that measure distance. Very step for you as well.
Perfect. So yeah, just a couple more minutes that are left, and we do want to be respectful of everyone's time. So if you do have any last second questions, please get them in now. General but application specific question. What time of day would you recommend is the best to be able to detect any water infiltration or heat loss on a rooftop?
Very good question. So during the day, especially summertime, you get solar loading. So there's something in thermal image called solar loading, which means that the object under sun is absorbing the energy of the sun, whether it's bricks, shingles, wood, whatever it may be, gyprock of a wall. It's absorbing. Remember, the energy, the sun is emitting a lot of energy, a lot of heat energy, and that's being absorbed by the surface and actually stored until there's a differential. So now the sun is giving so much energy, it's just capturing. And nighttime, sun goes down. And guess what it started doing? It starts emitting back that energy, right? So we typically say for roof leaks to try and do it either early in the morning before the solar loading, or very late in the evening after the chance that the surface has had a chance to kind of get rid of that, whatever it absorbed to a certain degree. So late evening or early morning is the best time.
Perfect. And we'll go last question. And I've gotten this a lot, can emissivity be calculated automatically?
So very good question. Not with our cameras specifically. It's not impossible to do, but you'd have to write code. We have customers who have done that. But to measure emissivity automatically, you basically have to compare two wavelengths. There are devices they call spectrometers where look at different wavelengths coming off the surface and they compare and they do automatic calculation. But there is a way to do it. I don't know. We don't have the cameras ready to go, at least not in the Teledyne Clear. Again, Teledyne has a lot of other divisions. They might be. I have other divisions that might have something like this. But in our particular case, we don't have a automatic emissivity measurement system.
Perfect. Okay, so it looks like those were all the questions that we got in. Everyone, thank you very much for sending in all those questions. That's great content and great follow-up to the fantastic presentation. So to be respectful, everyone, cut it off there. So Manny, a very big thank you for the presentation and sticking around and answering all those questions.
Thank you all.
And a very big thank you to all of you who participated in today's webinar. So on behalf of ITM University, thank you very much for your attendance today. We hope you found it informative and helpful. If we weren't able to address any of your questions directly, as mentioned previously, all your questions are stored and all your contact info. We'll be able to contact you directly after the presentation, as I mentioned to a few of our participants, as well as if you have any questions that do come up once we close out of here in a couple minutes, please feel free. Visit us on itm.com. You'll find, as mentioned earlier, product pricing, data sheets, our contact info, everything you'll need to get the answers to the questions that you're looking for. Keep in mind that at the end of this webinar, we will have a short survey that we'd appreciate if you completed. Your feedback will assist us in improving these webinars, bringing topics that are of interest to you. On that note, we do have upcoming webinars, so please visit the training page on itm.com to see our upcoming webinars. And don't forget, as a thank you for attending today's webinar, your name will be entered in a draw to win $100 for your next online order. The winner will be announced in our social media channels, so please be sure to check us out there. A very big thank you to you, Manny, for the presentation, and a very big thank you to all of you for taking time and participating today. Please have yourselves a wonderful day, and we'll see you soon.
Thank you, everyone. Take care.